There are nights when the universe seems to listen. The wind stills above the Atacama Plateau, and the telescopes wait like open ears against the dark. Part 1. The Whisper Before the Numbers. On July 1st, 2025, one of those ears the Asteroid Terrestrial Impact Last Alert System, ATLAS, detected a faint, moving point near the southern horizon. It was small, dim, and unusually fast. The automated system logged it as a near-Earth object candidate. Within hours, the Minor Planet Center issued an alert to observatories around the globe. By dawn in Hawaii, a follow-up from the Las Campanas Observatory confirmed an unexpected parameter. The eccentricity of its orbit exceeded 1, a clear sign it wasn't bound to the Sunday. Another interstellar visitor, the third ever recorded, after Oumuamua 2017 and Borisov 2019. It was given a temporary designation, 3I Atlas, the third interstellar object. For a few hours, it was just another anomaly in a sky full of anomalies. But then came the residuals. When astronomers calculated its expected position 24 hours later, the coordinates were off, not by much, only a few arcseconds, but the offset was systematic. Repeated observations confirmed a steady drift, as though a faint push was altering its motion. At first, the simplest explanations came: optical error, thermal noise, cosmic ray interference. Yet as the nights passed, each recalibration returned the same result. The object was accelerating ever so slightly, away from the curve predicted by pure gravity. The number was small, 0.02 millimeters per second squared. But in astrophysics, such small deviations rewrite entire models. A team at JPL's Center for Near-Earth Object Studies ran simulations using the OrbFit software. The predicted trajectory intersected a line near Earth's orbital plane sometime in mid-December 2025. That was all it took. Within a day, screenshots of the JPL ephemerides appeared on social media, stripped of their error margins and reinterpreted by algorithms hungry for drama. A headline spread: 3I Atlas is accelerating and on track to reach Earth. To the scientific community, this was premature. To the internet, it was prophecy. Threads erupted on Reddit's r, Space and X, formerly Twitter. Videos appeared claiming leaked data, citing inside sources from NASA. One viral post misread 1.8 astronomical units, about 270 million kilometers, as 1.8 million, shrinking cosmic scale by a factor of 100. That single typo ignited global anxiety. Meanwhile, in reality, the process was patient and methodical. Data flowed nightly from ALMA, Pan-STARRS, and Gaia DR3, cross-checked with the International Astronomical Union's databases. Astronomers used differential photometry to monitor the object's brightness, hoping to detect periodic variations, a sign of rotation or outgassing. The spectrum revealed weak cyanide lines near 388 nanometers, faint, but typical for comets. Still, something didn't fit. The pattern of acceleration wasn't random, and the outgassing jets didn't match the usual thermal orientation. Dr. Lina Alvarez, an astrophysicist at the University of La Serena, summarized it during a live Q&A. We're observing a natural object behaving in a way we can't fully model yet. It's not proof of intelligence, it's proof that we still don't understand every form of natural propulsion. But nuance rarely trends. Within hours, short-form clips stripped her quote to "behaving in a way we can't explain," and that became the soundbite of the month. From that point, two realities diverged. In laboratories, scientists chased precision. Online, people chased meaning. By early August, amateur astronomers joined the effort, contributing data from backyard telescopes via the Astrometrica network. Their collective observations confirmed the same anomaly, a tiny but measurable acceleration inconsistent with solar radiation pressure. A working hypothesis emerged: sublimation from buried volatiles, perhaps CO2 or ammonia ice. When these gases escaped, they produced a faint reactive thrust. The explanation fit the numbers but not the narrative, because in the public imagination, intentional motion is more captivating than chemical physics. Headlines grew louder. An interstellar object is changing course toward Earth. Talk shows debated whether it could be artificial. Memes mixed astrophysics with apocalypse. And yet, in professional circles, the mood was far more subdued. At a meeting of the European Southern Observatory, data analysts quietly refined orbital elements, noting that the course toward Earth was mostly illusion, a parallax effect, combined with Earth's own orbital motion. Still, the object's persistence fascinated everyone. Every telescope that pointed at it felt like part of a shared vigil. Inside the control room at ALMA, the screens glowed soft green. Engineers murmured over calibration logs. Each exposure revealed 3I, Atlas, inching forward through the void, its faint coma spreading like ink through water. No flashing lights, no metallic reflection, only the delicate whisper of physics doing what physics does perfectly, mysteriously. In a private memo circulated among observatories, an astronomer wrote, "There's beauty in our caution. Every time we measure, we acknowledge how little we truly know." Outside those walls, the digital storm kept growing. YouTube videos reached millions of views. Some claimed radio pulses at 1.4 gigahertzes. Others spoke of ancient prophecies aligning with the object's arrival. NASA issued a quiet press release on August 12. 3I, Atlas, poses no threat to Earth. Closest approach projected at 1.8 AU. Minor non-gravitational effects consistent with cometary behavior. Few read it. Fewer believed it. Because reason whispers, fear screams. Yet that whisper is where science lives. Each observation logged at 013 UTC, each spectral scan catalogued, each anomaly plotted against the silence of space. The astronomers waited, not for revelation, but for repetition, the only true form of proof. And in that repetition, the story began to shift. Beneath the noise of human imagination, a quieter truth started to emerge. That what we call mystery is often just patience wearing a different face. The night of July 17th, the Chilean sky was clear. 3I, Atlas, crossed a region near the constellation Sculptor, its path curving slightly predictable, traceable, yet somehow intimate. Dr. Alvarez recorded in her log, "It's strange to watch something that has travelled for millions of years and know that for a few weeks we are its mirror." And that's how the first chapter of this story closes. Not with discovery, not with danger, but with attention. Because before the numbers, before the analysis and the panic and the proof, there was only a whisper, the subtle, fragile realization that the universe is speaking all the time. We just haven't learned to listen without fear. Mirror line. The first step of every great discovery is to notice the difference between what is seen and what is imagined. And with that difference, the real investigation begins. Part 2. The acceleration nobody expected. At first, it was nothing more than a tiny anomaly, a decimal out of place, a faint curve where there should have been a line. In astrophysics, such deviations are common. Stars flicker, sensors drift, and even the cleanest data bears the fingerprints of imperfection. But this time, the deviation refused to disappear. The first detection came from the Chilean Atlas network, then confirmed by follow-up measurements from Pan-STARRS and the European Space Agency's Gaia Observatory. When astronomers plotted the residuals, the minute differences between where 3I, Atlas, should have been and where it actually was the line that should have been smooth began to bend. Not violently, not dramatically, but persistently. It was the kind of difference that whispers rather than shouts, yet every whisper said the same thing. Something unseen was pushing this object ever so slightly off course. By mid-July 2025, the deviation had compounded enough to reach statistical significance. The calculated change in velocity, or delta V, was measured at roughly 0.02 mm per second squared. To the untrained eye, that is meaningless, an acceleration slower than the growth of a shadow across a wall. But in the scale of celestial motion, it was a revelation. Gravity alone could not account for it. The sun's pull, the planetary perturbations, the Yarkovsky thermal effect, all standard corrections had been applied. Yet the numbers persisted. At the Jet Propulsion Laboratory, a small team began running differential orbit simulations. Their models predicted that if this acceleration remained constant for 50 consecutive days, 3I, Atlas's path, would gradually shift toward the Earth's orbital plane, not toward collision, but into alignment. It would pass within 1.8 astronomical units, roughly 270 million kilometers from Earth. A safe miss, but an uncanny trajectory. Dr. Raj Patel, an orbital dynamics specialist at JPL, recalled the moment he first saw the data. "It looked artificial," he admitted during an internal debrief. Not in the science fiction sense, but in the mathematical one. The acceleration had directionality and coherence. It behaved like an equation written with intent. The statement wasn't meant for the public, but when a journalist paraphrased it days later, the story mutated. Headlines screamed, NASA scientist admits 3I, Atlas moving with intention. Behind the sensationalism, the real puzzle remained. Non-gravitational acceleration is not unheard of. The comets experience it when sunlight warms their surface, causing jets of sublimated gas to propel them slightly, like invisible thrusters. But the vector of 3I, Atlas's acceleration, didn't match any plausible outgassing geometry. Instead of pushing away from the sun, as expected, the force appeared to act laterally, almost perpendicular to the solar wind. That single irregularity defied every thermal model. At the Harvard-Smithsonian Center for Astrophysics, another team attempted to reproduce the behavior using computational simulations. They modeled 3I Atlas as a porous body, possibly elongated, rotating every 6 hours. Even under generous assumptions about volatile content and surface temperature, they couldn't reproduce the measured thrust. Dr. Eleni Marinos, one of the researchers involved, summarized it in her notes. Either our assumptions about material composition are incomplete, or we're missing a new mechanism of momentum transfer entirely. As soon as the phrase "new mechanism" entered the conversation, the public imagination ignited again. In live-stream discussions, science communicators tried to translate the findings without feeding hysteria. "It doesn't mean it's alien," one said patiently. "It means physics still holds secrets." The Spartak, but online, patience is the rarest element in the universe. Within days, animations circulated showing 3I Atlas steering through space, its trajectory bending elegantly toward the inner solar system. The idea of intention, once merely poetic, became a digital fact, yet the deeper truth was stranger and quieter. Inside the control rooms, scientists weren't celebrating. They were scrutinizing. Each dataset was examined for measurement error. Could the offset be due to parallax from Earth's own orbit? Was there an unnoticed calibration drift in the CCD sensors? Could background noise have mimicked acceleration? To find out, observatories performed cross-calibrations. The Very Large Telescope in Paranal re-observed 3I Atlas using an independent spectrograph. Its readings matched ALMA's almost exactly. No bias, no systematic error. The anomaly was real, and with every verification, disbelief deepened. For the next month, the nights turned into a continuous relay. Observatories in Chile, South Africa, Spain, and Hawaii exchanged tracking duties so that 3I Atlas was rarely left unobserved. The combined dataset grew massive terabytes of raw photometric data, each frame time-stamped, each deviation mapped. The result was an elegant curve that no one wanted to believe. It rose gently, defying randomness, like a breath taken in a vacuum. When the curve was first projected on the wall at the ESA's Near-Earth Object Coordination Center, silence filled the room. Engineers stared at the numbers. Someone joked nervously that it looked like a comet with an opinion. It wasn't the acceleration itself that astonished them. It was the consistency, the way the numbers lined up night after night, as if obeying choreography unseen. The data from July 10th to August 28th formed a perfect exponential decay curve, exactly as if a source of thrust was slowly depleting. If it were natural, it would imply an internal process that self-regulates with time. If it were artificial, it implied design. Neither option sat comfortably within existing theory. NASA's Planetary Science Division released an interim report to prevent speculation from spiraling. Preliminary analysis indicates small but measurable non-gravitational forces consistent with asymmetric mass loss. The object's trajectory remains non-threatening, but in truth, consistent with, was cautious language code for "we're not sure yet." By late August, the conversation within professional circles shifted from what is happening to why this is happening so precisely. A few researchers floated unconventional ideas. Asterisk outgassing modulated by rotational shadows, creating thrust synchronized with spin. Asterisk interaction with charged particles from the heliospheric current sheet. Asterisk. Or, most controversially, light sail behavior acceleration driven by radiation pressure on a thin reflective surface. The last hypothesis carried the ghost of Oumuamua. When that object was first studied in 2017, a similar unexplained acceleration led physicist Avi Loeb to propose it might be an artifact of alien technology. The notion was dismissed by most peers, yet its echo now resurfaced. Could 3I Atlas be the sequel? The idea was tempting, maybe too tempting. The media seized it immediately. Talk shows quoted Loeb's earlier papers. YouTube channels filled thumbnails with silver discs gliding toward Earth. Meanwhile, The real work continued in silence. To measure something so small, astronomers turned to long baseline interferometry. 2 radio telescopes, one in Chile, one in South Africa, synchronized their data streams to detect micro-variations in the object's apparent motion. The results confirmed the acceleration again, now measured independently in 2 hemispheres. Statistically undeniable, physically unaccounted for. The more data they gathered, the less sense it made. When plotted against solar radiation intensity, the acceleration did not correlate. When compared to the rotational phase, no periodicity appeared. It was as if the object possessed its own agenda, an inner rhythm unrelated to sunlight or spin. Theories multiplied, papers drafted, preprints posted on RxIve faster than peer review could follow. Some invoked exotic physics, magnetic monopole interactions, plasma-driven thrust, even quantum vacuum drag. Others remained conservative, calling it complex outgassing under unknown thermal regimes. But the tone was shifting. Beneath the technical phrasing lay quiet wonder. Every night, a dozen teams pointed their instruments toward the same speck of light. The data poured in precise, consistent, and defiant. Each time they hoped to find an error, the universe answered with the same impossible confirmation. Every number whispered the same impossible story. In a midnight interview recorded for the European Space Research podcast, Dr. Alvarez sighed before the microphone and said softly, "Maybe it's not about what force is pushing it. Maybe it's about what's pushing us to keep looking." She didn't mean it philosophically, but listeners took it that way. The line spread across forums like poetry, and perhaps she was right, because the mystery of 3I, Atlas, was no longer just a question of physics. It had become a reflection of human nature, our refusal to accept silence without asking who might be whispering behind it. By the end of September, new measurements refined the trajectory again. The object would pass through perihelion in early October, and if the acceleration continued, its outbound path would diverge slightly toward Mars's orbital zone. Still safe, still distant, but now undeniably alive in mathematical terms. Scientists waited for the deceleration that never came. The numbers kept climbing slowly, steadily, impossibly, and so the mystery deepened. The next stage would demand not just observation, but imagination, because when logic falters, curiosity expands to fill the void. Every model that tried to cage the anomaly fell apart, except the simplest one, accepting that something in the universe, however small, was behaving outside our expectations, and that single realization was enough to reignite humanity's oldest instinct wonder. Part 3. The equation that terrified the internet. It began, as many modern myths do, with a screenshot, a cropped image of orbital data lifted from NASA's JPL Horizons system, stripped of its context, and reshared under a caption that no scientist had written. If the acceleration continues, impact possible on December 19th. No source, no error bars, no link to the actual dataset, just a sentence, floating through timelines like static charged with dread. Within hours, the screenshot had mutated. A YouTube channel with 2 million subscribers used it as a thumbnail, glowing red text over a blurred image of Earth. 3I, Atlas trajectory, intercepts orbit NASA silent. That single image, born from a line of code, would trigger one of the strangest waves of digital panic in recent memory. By morning, 3I Atlas was trending worldwide. Thousands of users began doing orbital math on their own, copying equations from open-source simulators, misinterpreting values, drawing curves on amateur plots. The number 1.8 AU, the projected miss distance, was mistakenly read as 1.8 million kilometers by several posts. The difference between millions and billions collapsed in an instant, and with it, reason. The panic spread not like fire, but like gravity pulling every conversation into its orbit. People recorded reaction videos. Others stitched together AI-generated animations of an object streaking toward the planet. One particularly viral clip compared 3I, Atlas's supposed trajectory, to that of the Chelyabinsk meteor, accompanied by slow, ominous music and captions like, "NASA knows more than they're saying." The comments beneath told their own story. Some prayed. Some accused governments of hiding the truth. And some, caught between curiosity and fear, just asked the question that the human mind has never stopped asking since the dawn of the telescope. What if? What if this time it really was coming? At the European Space Agency, astronomers watched the social reaction unfold with the same mixture of disbelief and concern that doctors reserve for patients refusing medicine. The math was simple, the error obvious, but the psychology ancient. Because in moments like this, data isn't just information, it's a projection. We pour into it every fear that has ever haunted our collective imagination: extinction, insignificance, abandonment. We look into the mirror of the cosmos and see our own anxiety reflected. Inside, a cluttered dorm room in Sao Paulo, a physics undergraduate named Luis Aranda tried to calm the chaos by posting an explanation thread on X. No, 3I, Atlas, is not going to hit Earth. The JPL data shows its minimum distance will be about 270 million kilometers. That's farther than Mars. Please stop spreading panic. He included plots, references, and even official links. But reason travels slowly in a network designed for speed. His post reached 12,000 views. The panic post surpassed 12 million. Elsewhere, a group of content creators saw an opportunity. Countdown to Impact channels emerged overnight, streaming animated countdown timers. Donations poured in. Fear became monetized, algorithmically reinforced, dressed as curiosity. The irony was cosmic. A civilization that could decode light from distant stars could not decode its own emotional algorithms. On Reddit's astronomy, professionals and amateurs clashed. A user named AstroGuard87 wrote, "These fearmongers are damaging public trust in science. The object will not come anywhere near us." Someone replied, "That's exactly what they said before the Tunguska event." The thread exploded with speculation, references to biblical prophecies, and jokes about humanity's last memes. Meanwhile, at NASA's Planetary Defense Coordination Office, analysts quietly released an update to clarify the confusion. Trajectory projections show no credible impact risk for 3I, Atlas. Current orbital solutions indicate a safe passage at 1.8 AU, but to most viewers, the correction never appeared. Algorithms reward engagement, not accuracy, and engagement thrives on fear. Within a week, the equation, the now infamous orbital calculation showing a near-Earth line, had become the center of a cultural phenomenon. News outlets published think pieces. TikTok astrologers linked it to planetary alignments. Even late-night comedians joked about the comet that's allergic to facts. A cognitive scientist from MIT, Dr. Hannah Song, analyzed the event and coined the term confirmation hysteria, a state in which collective anxiety overrides numerical comprehension. Humans evolved to detect predators, not pass probability, she said. So when faced with uncertainty, our brains translate decimals into danger. And indeed, that's what happened. Every graph, every chart, every scientific attempt at reassurance was read emotionally, not rationally. A live stream hosted by an independent researcher tried to demonstrate orbital mechanics in real time. He used 3D software to show how the line between Earth and 3I, Atlas, only appeared to intersect due to perspective, the same reason distant highways seem to converge. But halfway through the broadcast, the chat filled with accusations of censorship. "Why are you hiding the truth?" one user wrote. Others spammed skull emojis and countdown clocks. The more he explained, the less they listened. It was, as one observer later wrote, like shouting fire in a theatre of galaxies. In classrooms, professors began using the event as a teaching moment. The 3I, Atlas Panic, as it was called, became an instant case study in science communication, how an innocent data point can mutate into digital mythology. At the University of Cambridge, a media analysis team tracked the spread. Asterisk, first 12 hours, 14,000 mentions across platforms. Asterisk, after 48 hours, 2.1 million. Asterisk. By the end of the week, 46 million engagements, spanning 19 languages. It wasn't the largest misinformation event of the decade, but it was perhaps the most poetic, a misunderstanding written in starlight. During that same week, Dr. Lina Alvarez, still in Chile, was part of a live interview for a Spanish-language science channel. She tried to explain the math calmly. An orbit is not a straight line. When we plot data points, perspective creates intersections that don't exist in three-dimensional space. Her voice trembled slightly, not with fear, but fatigue. She had spent 2 weeks fighting ghosts made of pixels. When the interviewer asked why so many people were convinced of an impending collision, she paused. "Because numbers can feel cold," she said. "And when people are afraid, they listen to warmth, not logic." That sentence spread nearly as fast as the panic itself. Clipped out of context, it appeared in countless videos with captions like, "NASA scientist admits something deeper is happening," No one noticed that what she meant was empathy. By late September, the wave of fear began to subside, not because truth triumphed, but because attention drifted. A new trend, a different crisis, another mystery claimed the spotlight. The human mind, restless and insatiable, moved on. But in the archives of the internet, the digital fossils of that panic remained. Millions of comments, videos, and speculative posts, each one a monument to our fragile relationship with the unknown. When researchers later analyzed the metadata, they found something remarkable. Engagement peaked exactly 6 weeks before the predicted impact date, a psychological sweet spot known in behavioral science as the anticipatory window, the perfect balance between fear and fascination. In other words, the panic was not random, it was timed by the architecture of human curiosity itself. In the aftermath, educational channels released explanatory videos to restore context. Slowly, clarity returned. People began to understand that 3I, Atlas's so-called Earth intercept, was nothing more than a two-dimensional illusion, a projection of orbits that only seemed to overlap when flattened into charts. Yet the lesson lingered, that in the age of instant information, even equations can become emotional triggers. Behind every trending topic, there's a shadow. Our collective desire to feel involved in something cosmic, to find ourselves reflected in the data, even when that reflection distorts reality. Weeks later, when a journalist asked Dr. Patel what he thought of the panic, he smiled gently. It reminded me that science isn't just about numbers, it's about trust, and trust moves slower than light. The audience fell silent for a moment, because deep down, everyone knew he was right. The panic wasn't born from malice. It was born from longing, the same impulse that makes us gaze at stars and wonder whether they gaze back. And perhaps that is why even after the fear faded, the fascination endured. 3I, Atlas, had become more than a visitor from another system. It was a mirror, reflecting the strange geometry of human emotion. In the end, the equation that terrified the internet wasn't just an equation. It was a story, one written by our inability to separate mystery from meaning. Every era has its own superstition. Ours just happens to come with coordinates. And so, as the digital noise slowly faded into silence, the real scientists turned back to their instruments, letting the numbers speak again in their quiet, unassuming language. A few of them smiled, knowing that somewhere, hidden beneath the panic, was a profound truth, that humanity still cares enough to be afraid. That, in its own way, is evidence of life. Part 4. Between Numbers and Imagination. When the storm of speculation finally began to quiet, what remained was silence, the kind that only follows exhaustion. The internet had moved on to other fears, leaving behind a wake of confusion, fascination, and a few thousand wrong equations. For the scientists who had lived through the noise, the silence was not relief. It was a responsibility. In the control rooms of observatories, researchers went back to the slow work that social media rarely celebrates: observation, hypothesis, and verification. The real process of science begins when emotion ends, and it almost always begins in quiet rooms filled with patient people. Every dataset from July and August 2025 was re-examined from the start. Teams compared positional measurements from different telescopes, corrected for atmospheric refraction, recalculated exposure biases, and even checked for software rounding errors. The question wasn't, what is 3I Atlas, anymore. It was, what can we actually prove? That single shift from story to method is the invisible moment when hysteria dissolves and clarity begins. At the European Southern Observatory, a technician named Annika Hauer spent 3 nights aligning timestamps across instruments located thousands of kilometers apart. A small discrepancy, 3 milliseconds, had appeared in one dataset. For most viewers, such precision would sound absurd, but in celestial mechanics, 3 milliseconds can change everything. The updated plots aligned perfectly. The acceleration remained real but explainable, a stable force consistent with volatile outgassing as the object neared perihelion. No mystery required, only patience and precision. Still, even this ordinary conclusion felt almost miraculous after the weeks of chaos, because rationality, when rediscovered, carries its own kind of beauty. Across scientific institutions, the cleanup continued like an intellectual dawn. At JPL, algorithms were rerun with corrected parameters. At ESO, spectral lines were reprocessed using higher signal thresholds. At ALMA, a new calibration sequence removed thermal noise artifacts that had amplified false readings. One by one, the pieces fell into order. The story grew less exciting but more real. The scientific method, at its core, is a conversation between humility and evidence. It begins with, "I don't know," then moves to, "Let's see." Then, after hundreds of trials and sleepless nights, it finally whispers, "This is what the data seems to say for now." It is a process that invites revision, not pride, and in that openness lies its strength. What many outside the field rarely realize is that discovery and correction are not opposites. They are partners. Science advances not because it is certain, but because it is willing to be wrong beautifully. The hysteria surrounding 3I, Atlas, reminded researchers why this distinction matters. Imagination without method creates fantasy. Method without imagination creates silence. But when the two work together, truth begins to shimmer. In late September, NASA's Planetary Defense Coordination Office hosted an open webinar titled "How We Measure the Unknown." Thousands joined, expecting sensational updates. What they heard instead was something more profound, a lesson in patience. Dr. Raj Patel, who had been at the center of the orbital analysis, spoke slowly, his tone calm and deliberate. "Science doesn't move at the speed of panic," he said. "It moves at the speed of verification. We observe, we test, we fail, we try again. Reality doesn't need our permission to be consistent." A pause followed, not applause, just quiet comprehension. It was the kind of silence where minds actually think. He explained how every hypothesis, no matter how compelling, must survive 3 trials: observation, replication, and falsification. If it can't be measured again, he said, it doesn't exist. If it can't be falsified, it isn't science. And if it can't be explained yet, that only means our curiosity has more work to do. That sentence, simple as it was, marked a turning point. Viewers began to understand that the real excitement of science isn't in conclusions, it's in the courage to question them. Meanwhile, in classrooms and planetariums, educators used the 3I Atlas incident to teach students the anatomy of truth. One teacher in Italy projected 2 overlapping diagrams on the wall, the viral orbit from social media and the corrected orbit from JPL. They looked almost identical to the casual eye except for a few degrees of tilt. She asked her students to find the difference. Most couldn't. Then she smiled and said, "This is how belief looks when it meets precision." The room fell silent. That silence was education. Elsewhere, independent astronomers began to publish their findings in online journals, showing meticulous step-by-step analyses. Each report included uncertainties, caveats, and margin of error tables, all the things that never go viral, yet hold civilization together. For every rumor that spreads in seconds, there are 1,000 quiet hours of method that no one notices. But that is how knowledge endures. A month after the panic, Dr. Lina Alvarez wrote a paper titled "Quantifying Uncertainty in Public Science Communication." Her opening line read, "The most misunderstood word in modern science is uncertainty. To the public, it sounds like weakness. To scientists, it is the measure of honesty." The steel of friend, that phrase echoed across conferences for the rest of the year. Because she was right, uncertainty isn't the opposite of truth, it's its framework. In this new calm, researchers started speaking more openly about their process. They shared behind-the-scenes footage of data verification, the unglamorous reality of science. Rows of code, calibration curves, nights spent realigning instruments under freezing wind. There was beauty in that mundanity, the reassurance that reality still obeys laws, even when we forget them. The contrast between hysteria and method became clear. Where fear shouts, science whispers. Where misinformation multiplies, observation patiently narrows. Where imagination leaps, verification walks slowly, steadily, toward clarity. Even outside the labs, something shifted. On YouTube, a creator who had once fueled panic posted a quiet apology. "I got caught up in the fear," he admitted. "I didn't check my sources. I forgot that science is about questions, not conclusions." The video went viral not for its drama, but for its humility. It became one of the few times the internet applauded restraint. Back in Chile, the sky began to change. By early October, 3I, Atlas, was bright enough to be visible through medium-sized amateur telescopes. For those who watched carefully, it was no monster, no omen, just a faint streak of light tracing its path across the stars. Dr. Alvarez, standing at the observatory's balcony, looked up and murmured to a colleague, "All that noise, and it was always this quiet." That sentence captured the essence of the whole episode. The hysteria had never been about the object itself. It had been about the human heart, forever torn between wonder and worry. When data became myth, and myth became fear, science had offered the simplest possible answer. Look again. The story of 3I, Atlas, was no longer just an astronomical event. It had become a philosophical mirror. It showed how fragile perception is, how easily imagination can outrun understanding. But it also showed the antidote: humility, discipline, and the courage to measure again. And that is what they did. Night after night, telescopes watched, computers processed, and equations were rewritten. Each iteration brought the trajectory into sharper focus. Each remeasurement stripped away another layer of myth. By the second week of October, the data had converged. The object's motion was fully reconciled with the physics of natural outgassing. Its mystery acceleration was now predictable, a sigh of vapor against sunlight. No longer terrifying, just real. And in that ordinariness lay something profound, because science, at its most honest, doesn't diminish wonder, it refines it. Under the vast Chilean sky, a final log entry was made that night. The observation timestamp read 3:22 UTC. The object's position matched the model to the third decimal place. The noise, both literal and metaphorical, was gone. The entry ended with one quiet line. Every discovery begins with imagination, but only observation can turn it into understanding. The balance had returned, and somewhere between numbers and imagination, the world exhaled. Part 5. Eyes of the Sky. The Global Observation Network. By early October 2025, 3I, Atlas, had become more than a scientific anomaly. It was a shared horizon. From the deserts of Chile to the mountains of Hawaii, from the dry plateaus of Spain to the frozen plains of Antarctica, telescopes across the planet pointed toward a single moving dot cutting through the night. It was a rare moment when humanity, fractured by so much noise, looked in the same direction. At the Atacama Large Millimeter Array, ALMA, engineers adjusted receivers to capture microwave reflections from the object's faint coma. The desert air was still, the horizon glowing faintly with the aftertaste of sunset. Rows of satellite dishes rotated in unison, their mechanical whir like a synchronized breath. From a distance, they resembled an orchestra tuning to the same cosmic note, hundreds of lenses turning toward the same streak of light. Thousands of miles away, at the European Southern Observatory's Paranal site, the Very Large Telescope, VLT, was prepped for a deep-field optical sequence. Its massive domes opened like slow eyelids against the dark. Inside the control room, a faint green glow from monitors washed over scientists hunched over data feeds. Each image captured would take 20 minutes to render. Each pixel, a fragment of an interstellar visitor's story. For the first time since the early days of the James Webb Space Telescope, the world's instruments worked as one, a choreography of focus across continents. At NASA's Goddard Space Flight Center, operators of the Hubble Space Telescope planned a coordinated observation window with JWST 1.5 million kilometers away at the Lagrange point L2. It was a logistical ballet, Earth's rotation, orbital dynamics, and communication relays had to align perfectly. At 3:04 UTC, both telescopes locked onto 3I, Atlas, within minutes of each other, one in visible light, the other in infrared. The resulting composite was breathtaking. A small, pale object trailing a barely visible plume, a whisper of dust and vapor drifting between the constellations Sculptor and Grus. Not spectacular, not cinematic, just impossibly real. For scientists, it was a triumph of precision. For everyone watching online, it was a reminder that collaboration still existed in a world often divided by everything else. The JWST team released the first processed image to the public 2 days later. It showed 3I, Atlas, as a faint golden blur, framed by the deep red haze of interstellar dust. The caption read simply, "Observation confirmed. Object remains stable. Non-gravitational forces consistent with thermal activity." But the image carried more than data. It carried meaning, the quiet poetry of distance made visible. Social media lit up again, but this time, not with panic. Comments were full of awe. People wrote things like, "I can't believe we're watching something from another star system." For a brief moment, the collective gaze of millions turned from fear to wonder. In Hawaii, the Subaru telescope at Mauna Kea joined the observation campaign. Its adaptive optics corrected for turbulence in the thin mountain air, capturing spectral fingerprints of gases escaping from the object's surface. traces of carbon monoxide, faint ammonia typical of comets, yet carried on a trajectory that defied belonging. Dr. Yuki Sakamoto, leading the Mauna Kea analysis, described it perfectly during an interview. It's not just a rock passing by, it's a fragment of another system's history, brushing against ours. He's Romanov, which is a brief. As she spoke, she pointed at the live display of the tracking system. A thin green line traced 3I, Atlas, across the sky, moving almost imperceptibly. Every few seconds, the telescope recalibrated its aim, tiny pulses of mechanical correction to follow a target that had crossed light years. On the other side of the world, the Atacama Pathfinder experiment, APEX, captured microwave emissions to model the object's rotation. Preliminary data suggested a rotation period of 8.7 hours, slower than expected, implying that the acceleration observed earlier might have altered its spin. Each dataset added another piece to the puzzle, another heartbeat to an object once thought inert. By mid-October, the Global Observation Network had grown into a true alliance, more than 40 observatories across 17 countries, contributing data to a central repository managed by the International Astronomical Union, IAU. Their communication channels buzzed constantly. New readings, calibration notes, spontaneous discussions about data anomalies. It felt less like bureaucracy and more like a living organism, a planetary nervous system reacting to a stimulus from beyond. For the first time, telescopes that normally competed for observation time shared their schedules willingly. Even amateur astronomers joined, uploading measurements from their backyard setups to the open AstroSync network, where AI-assisted software verified accuracy and compiled results in real time. In small towns and big cities, telescopes appeared on rooftops and balconies. Children stayed up past midnight to glimpse the faint smear of light gliding silently among the stars. No one could truly see 3I Atlas without advanced equipment, but that didn't matter. What mattered was that people looked. The act of looking itself became sacred. News outlets began calling it the Night of 1,000 Telescopes. In one live broadcast from the European Space Operations Centre, Dr. Eleni Marinos summarized what made this event different. We've studied countless comets and asteroids, but this time, it's not just observation, it's participation. The whole world is observing together. We are one data point in the universe, and tonight we're aware of it. The phrase spread instantly. Clips from observatories across the world merged into montages. The rotating dishes of ALMA, the glinting mirrors of Hubble, the silent precision of JWST's sunshield reflecting faint starlight. Each image pulsed with a shared rhythm, the heartbeat of collective curiosity. Back in Chile, the ALMA control room fell into an unusual stillness. Technicians watched as data streamed in line by line, a cascade of signals from antennas spread across the desert. The faint hum of electronics mixed with the sound of wind brushing against the domes. At that moment, the distance between human minds and interstellar dust collapsed into a single act: listening. There was no competition, no ideology, no noise. Only the steady rotation of the planet beneath an unbroken sky and the quiet cooperation of thousands who had never met. The Hubble team, orbiting 540 kilometers above Earth, sent back another image. 3I, Atlas, against a field of distant galaxies, each one a reminder of scale. It was humbling, the realization that even as we studied something small, we were surrounded by the vastness that birthed it. At JWST, infrared data began revealing the thermal signature of 3I, Atlas's outgassing. It wasn't uniform, it pulsed. Every few hours, faint waves of emission radiated outward like breaths. The data analyst stared at the graph in silence. The pulse wasn't perfectly regular, but it was undeniably rhythmic. Was it a coincidence, rotation, or a pattern born of physics we hadn't yet modelled? Dr. Patel at JPL smiled faintly when he saw the preliminary results. Every time we think the mystery's over, the universe leaves a note that says, "Not yet." And so the campaign continued. Each night added new clarity and new questions. Each sunrise brought exhaustion and awe in equal measure. The collaboration stretched beyond astronomy. Computer scientists built models to cross-correlate global data. Musicians began turning frequency readings into soundscapes. In Copenhagen, a choir performed a piece titled Trajectory, composed from radio noise recorded by ALMA. Its haunting harmonies were broadcast worldwide, a hymn to a traveller between stars. The data, the art, the global attention, all of it was proof of something deeper than curiosity. It was proof of connection. For once, humanity wasn't arguing about what it meant, they were simply looking together. As 3I, Atlas, approached its closest distance from Earth's orbital plane, an anticipation spread again. But this time, it wasn't fear. It was reverence. Live streams counted down to the alignment moment, not with dread, but with excitement. When the timestamp arrived, the 19th of October 2025, 2110 UTC, the object crossed the virtual plane of Earth's orbit, a speck of dust from another star, skimming the invisible path our planet follows around the Sunday. The world watched through screens and telescopes. Some prayed, some simply stared. For a few seconds, no one argued about distance or data or meaning. It was just light meeting light, a tiny spark of shared existence between worlds. And as that glow drifted onward, shrinking into the background of infinite black, scientists everywhere took a deep breath. The campaign wasn't over, but something profound had already happened. A planet divided by everything had found unity in a single point of motion. Somewhere in the logs of Alma, a technician typed the final entry of the night. Signal confirmed. Trajectory nominal. Humanity synchronized. Outside, the stars shimmered as if approving. The universe hadn't sent a message. We had to ourselves. Part 6. The Voice of Data. For all the beauty seen through the telescopes, the true story of 3I, Atlas, lived elsewhere, not in the sky, but in the data. In lines of numbers stretching across screens, in scatterplots that only a patient's mind could translate into meaning. Data is often called the language of the universe. But what we forget is that language can whisper as easily as it can shout. After the great global observation campaign, the raw telemetry began to pour in. Terabytes of readings from every instrument in the network, astrometry data from Gaia, spectral telemetry from JWST, microwave interferometry from ALMA, and visible light tracking from Hubble. Every file contained not answers, but possibilities. Each pixel, each digit, was a question waiting for the right listener. At the IAU Data Processing Center in Geneva, a team of analysts began to piece together this flood of information. Rows of screens flickered with graphs, color-coded anomalies, and confidence intervals. The room looked less like a laboratory and more like a quiet monastery of logic. Each scientist spoke softly, as though noise itself could alter the results. They started with astrometric data, the precise positions of 3I, Atlas, over time. Using triangulation from multiple observatories, they plotted the motion of the object across a three-dimensional grid. From these coordinates came the refined orbit, the trajectory stripped of rumor and imagination. What emerged was humble, almost anticlimactic. 3I, Atlas, was exactly where it was supposed to be, and going exactly where gravity dictated. The once feared acceleration was still present, but smaller than early estimates suggested. Statistical analysis revealed that what had been interpreted as a steady force might actually be a complex mixture of probabilistic noise and minor outgassing, the kind seen in many long-period comets. When the final error bars were drawn, the pattern was clear. The universe wasn't misbehaving, our interpretations were. For weeks, the teams worked through every variable. They built error budgets, measuring everything that could distort perception: atmospheric interference, sensor drift, phase noise, parallax bias. They even simulated how internet compression had warped early shared images, making the object appear to jump in position. The data wasn't lying, the pixels had been misread by human impatience. At JPL, Dr. Patel summarized it perfectly during a debrief. The numbers never exaggerate. People do. His words weren't criticism, they were compassion. Because behind every misinterpretation lies the same impulse that drives discovery, the desire for meaning. Humans are pattern-seeking creatures. When we see motion, we assign purpose. When we see light, we imagine intelligence. But data has no ego. It simply is. When interpreted without bias, it tells a humbler truth, one that doesn't headline easily but endures quietly. In late October, Dr. Alvarez and her team at ALMA published their contribution to the collective dataset. They included not just the results, but the entire chain of reasoning from raw calibration frames to final graphs. Anyone could replicate their process. Transparency became the antidote to hysteria. Her opening paragraph read like a manifesto. Astrometry is not the art of certainty. It is the discipline of listening to uncertainty until it speaks coherently. Those words circulated among research communities and soon found their way into the public domain, quoted in think pieces and documentaries. The hysteria of earlier months began to feel distant, almost archaic. The world had moved from emotion to evidence. Inside the data labs, the atmosphere shifted from tension to wonder. Each new analysis revealed the quiet elegance of celestial mechanics, the slight curve of a path, the resonance of orbital harmonics, the faint thermal echo of sunlight bouncing off frozen dust. It was no longer about survival or fear. It was about listening not to signals but to silence arranged into numbers. Scientists often speak of letting the data speak for itself, but what they rarely say aloud is that the data does speak, just not in a human tongue. It speaks in probabilities, in margins, in curves that approximate truth but never quite reach it. To understand that voice requires humility, the willingness to accept that knowledge is always partial, always provisional. In one corner of the Geneva Data Center, a young analyst named Marina Duval noticed something subtle while comparing radio telemetry from ALMA and optical data from Hubble. A slight phase delay less than 0.04 seconds between signal detection and optical alignment. It was insignificant, within expected error, but she smiled anyway, because even in error, she saw rhythm, the soft pulse of reality reminding her that perfection doesn't exist, only precision approached asymptotically. Across the world, thousands of other analysts were performing similar acts of devotion. Each click, each calculation, was a small gesture of faith. Faith that truth, even when surrounded by noise, could still be found. In November, the first unified model of 3I, Atlas's behavior, was released. It concluded that the object's non-gravitational acceleration had gradually diminished after perihelion, following a logarithmic decay consistent with sublimation loss. In plain language, it was a natural traveler, not a machine. The final graph looked beautiful, a gentle slope descending into stillness, like a heartbeat calming after exertion. It wasn't the revelation many expected, but it was a revelation nonetheless, because behind that curve was the story of human restraint, the art of stopping before declaring the extraordinary. When the findings were announced, one journalist asked Dr. Patel if he felt disappointed that 3I, Atlas, turned out to be ordinary. He smiled faintly. "Ordinary things," he said, "become extraordinary when we actually understand them." His comment struck a chord. In a world addicted to the dramatic, there was something radical about celebrating simplicity. The final dataset, nearly 60 terabytes, was made open source. Anyone with curiosity could explore it. Students downloaded the files, teachers used them for lessons, and data visualizers transformed them into breathtaking 3D renderings of motion. The object's journey, once cloaked in fear, became an educational symphony. One visualization spread across the internet, a glowing blue line representing the object's path from interstellar space through the solar system and back out again. At the top of the video, a caption read, "Reality needs no embellishment." That phrase became the unofficial motto of the entire campaign. And in that clarity, something shifted not just in science, but in culture. The incident became a metaphor for discernment in an age of overload. The idea that behind every story, every claim, there lies a quieter layer of evidence waiting to be heard. Late one evening in November, Dr. Alvarez recorded a note for her students. "Data is a conversation. The universe speaks in uncertainty, and our task is to answer with patience. Every time we mishear it, the cosmos gently corrects us." He does not from there. That recording, meant for a classroom, found its way online and was played over montages of telescopes, graphs, and star fields. It became one of the most watched science clips of the year, because people weren't just looking for information, they were seeking peace in information. The voice of data had become a lullaby against the chaos of speculation. By the end of 2025, the last coordinated observations of 3I, Atlas, were logged. The object was now receding toward the outer solar system, fainter with each passing night. The datasets were complete, the conclusions cautious but solid. What lingered wasn't mystery or fear, but gratitude. Scientists worldwide wrote quiet reflections, each in their own way saying the same thing, that for all our telescopes and equations, the greatest discovery wasn't about the object itself. It was about learning, once again, to trust what is slow, measured, and real. One final line appeared in the summary report filed by the IAU, buried near the end of a dense appendix. Few noticed it, but those who did never forgot. The data showed nothing supernatural, only nature behaving precisely as it should, and in that precision, we found something divine. The numbers had spoken, and their voice, steady and kind, reminded the world that truth doesn't always roar. Sometimes, it simply breathes. Part 7. Nature's imitation of intention. By the time the data had been unified and the panic had settled into curiosity, one question still lingered at the edges of every conversation, a question that no amount of error correction could entirely silence. If 3I, Atlas, was natural, why did it behave as if it weren't? Even with the final models in hand, there remained that tantalizing detail. A brief period in mid-August when the acceleration appeared to change direction in a way inconsistent with sunlight pressure or rotation. For a few days, it had behaved like something responding to an invisible instruction. To most scientists, the explanation was mundane, cometary outgassing. When sunlight strikes volatile ices buried beneath the surface, the gases escape through cracks and fissures, creating faint jets that act as miniature thrusters. In a vacuum, even the smallest release of vapor can nudge a mountain of ice across millions of kilometers. But something was haunting in how precisely 3I, Atlas, seemed to respond. Its deviation wasn't random. It was rhythmic. At the Harvard-Smithsonian Center for Astrophysics, Dr. Eleni Marinos compared it to an orchestra tuning itself without a conductor. "It's chaotic," she explained, "but it never loses the rhythm. It's as if nature composes intention through randomness." That phrase, nature composing intention, captured the mood perfectly. The scientific community had seen this kind of pattern before. When Oumuamua crossed our solar system in 2017, its acceleration had sparked the same speculation. At the time, physicist Avi Loeb had proposed that it might be a fragment of alien technology, a light sail, propelled not by engines but by sunlight itself. The idea was radical, even heretical, but it never truly died. And now, 8 years later, the ghost of that hypothesis stirred again. Could 3I, Atlas, be another? At first, the suggestion circulated quietly, a few private emails between colleagues, an aside during a conference in Prague, a speculative paragraph buried in an appendix. But once the idea escaped into the open, it spread like electricity. The reasoning was subtle but seductive. If the object's surface were unusually reflective, say, composed of thin, carbon-based or metallic layers, the radiation pressure from sunlight could generate just enough thrust to explain the acceleration. No outgassing required, no heat signatures, no visible jets. It would mean that the object was functioning like a solar sail technology that humans themselves had only begun to master. The resemblance was uncanny. The numbers worked. The imagination followed. Still, the more cautious voices spoke first. At the European Space Agency's Orbital Mechanics Division, Dr. Patel reminded the team of an older truth. "Physics loves simplicity," he said during a briefing. "Before we imagine engineers, we should first imagine sunlight." They tested the reflective hypothesis anyway. Simulations were run using different albedo values: 0.05 for dark rock, 0.3 for ice, up to 0.9 for polished metal. Only the most extreme reflectivity could produce the observed acceleration, and even then, the angle of deflection didn't fit perfectly. The models failed to converge. Nature, it seemed, was mimicking design but not obeying it. Still, the idea refused to die. The public, still haunted by the poetic legacy of Oumuamua, wanted a sequel. Articles appeared with titles like "Another Visitor, Another Mystery," and "Did the Universe Send a Second Probe?" To readers hungry for wonder, the distinction between possible and probable blurred into irrelevance. Inside the observatories, though, the mood was different, not dismissive, but contemplative. Scientists are human too. They dream. For every paper that debunked artificial origin, another was written exploring how natural processes could imitate technology so convincingly. At ALMA, the Chilean team tested thermal emission profiles, comparing them to the expected patterns of a light sail structure. If 3I, Atlas, were flat and thin, its rotation would produce sharp periodic dips in brightness, a strobe-like flicker as it tumbled through sunlight. But no such flicker appeared. The light curve was irregular, organic, full of soft transitions, the messy handwriting of nature. And yet, something about it still felt intentional. Perhaps it wasn't the object that was intentional, but the universe itself, an artist painting order with the brush of entropy. The longer scientists studied the behavior, the more the boundary between biology and physics seemed to blur. Self-regulation, feedback, oscillation. These weren't unique to life or machines. They were laws, written deep into matter itself. Dr. Marinos, in a late-night interview, said it quietly but memorably. When nature behaves like intelligence, maybe that's because intelligence is just nature folded back on itself. The line resonated far beyond academic circles. It became a kind of mantra, bridging believers and skeptics alike. Podcasts discussed it. Artists painted it. Even a popular science magazine featured it on its cover, beside a digitally rendered image of 3I, Atlas glowing like a drifting lantern among the stars. Behind the poetry, however, the data spoke plainly. Spectroscopy revealed faint cyanide and carbon monoxide, definitive signs of sublimation. Temperature gradients matched those of comets from the Oort cloud. There was no metallic reflection, no coherent radio emission, no signs of engineered material. The object, for all its elegance, was natural, but that didn't make it less fascinating. It made it more so, because in that confirmation lay a deeper revelation. Nature itself can behave like intention, not through will, but through complexity. When the JWST infrared team published their final dataset, they included an appendix comparing the energy output of 3I, Atlas's jets, to the theoretical thrust of a 1-kilometer solar sail. The numbers were almost identical, a coincidence, but a breathtaking one. It was as if physics had written the same equation twice, once in the language of life, once in the language of matter. For the scientific community, this symmetry was awe-inspiring. It reminded them that technology and nature are not opposites. They are reflections of the same underlying logic. A few bold thinkers began exploring the idea that perhaps the boundary between natural and artificial is illusory. If intelligence arises from the universe, then its creations are not separate from it. A probe made by alien hands would still be an expression of the cosmos, another branch of its own self-organization. That thought alone was enough to quiet the old argument. Whether 3I, Atlas, was designed or spontaneous, it belonged to the same unfolding story, the cosmos, learning itself through motion. Dr. Alvarez, who had grown weary of both panic and speculation, wrote in her journal one night, "We keep asking whether it's natural or artificial. Maybe the universe doesn't draw that line. Maybe every comet is a messenger, whether it knows it or not." His note likes not. Her entry would later be quoted in a documentary, her voice calm over the sound of wind sweeping across the observatory dome. There, she explained what many scientists had begun to feel, that fascination doesn't need certainty. To stand between wonder and evidence is not a contradiction. It's the essence of science. In a late December conference, when someone asked whether she personally believed 3I, Atlas, was a product of intelligence, she smiled. "Of course it is," she said. "Just not the kind you're thinking of. It's the intelligence of physics, the geometry of probability, the symmetry of everything that moves and remembers." The audience went quiet, and perhaps that was the best answer of all, one that satisfied both sides of the human mind. Rational enough for scientists, poetic enough for dreamers. The final papers released by NASA and ESA closed the debate formally, natural origin confirmed. But in the hearts of many, the wonder remained unresolved. Because even if 3I, Atlas, was nothing more than ice and dust, it had behaved like a thought, fleeting, deliberate, and impossibly far from home. And so, long after its light had faded from telescopes, the question endured. What if every movement in the universe, however small, is a kind of conversation matter trying to remember where it came from? Whether engineered or elemental, 3I, Atlas, had achieved something no machine or comet had done before. It had made humanity look at the boundary between reason and imagination and find beauty in the blur. The night that realization settled in, Dr. Patel closed his final report with a sentence that would outlive the event itself. Perhaps the greatest sign of intelligence in the universe is that nature learned to imitate it. Part 8. The Dark Forest Hypothesis. The more clearly scientists understood 3I, Atlas, the deeper the unease grew. Not fear of impact, nor of alien invasion, but of something subtler, quieter, a question that lingered after the equations ended. If the universe is full of life, then why is it so silent? This is the paradox that has haunted astronomers for decades. The Fermi paradox, once academic, has become personal. The discovery of every interstellar object sharpens it. Each visitor that passes through our solar system without sending a signal is another unanswered knock on the cosmic door. In 2025, as telescopes followed 3I, Atlas, on its outbound path, whispers of this old question resurfaced in public forums and conferences alike. The fascination had evolved from, "Is it artificial?" to, "Why does it feel like someone's avoiding us?" The idea wasn't new. In 2008, Chinese author Liu Cixin gave it a name that would echo through generations: the dark forest hypothesis. In his story, the universe is a vast forest filled with hunters. Each civilization is a flicker of firelight, cautious of revealing its position. Because in a cosmos without rules, survival may depend on silence. Perhaps the reason we hear nothing, the theory suggests, is not because no one is speaking, but because everyone is whispering. To many, the concept feels chillingly plausible. Space, vast and indifferent, becomes an ecosystem where existence itself is a risk. Every signal is a declaration. We are here, and every declaration, a potential invitation to extinction. In late 2025, as the data from 3I, Atlas solidified its natural identity, a series of think pieces began connecting the dots between the object's silent passage and humanity's growing awareness of its cosmic vulnerability. One headline captured it perfectly. Maybe we're not alone, we're just being ignored. At first, scientists dismissed it as philosophical overreach. But even among the rational, the thought lingered, because silence, when stretched across billions of years and trillions of kilometers, begins to feel intentional. In the observatory at Paranal, Dr. Lina Alvarez sat beneath the red glow of instrument panels, watching telemetry lines scroll past. The object was leaving the inner solar system, fading from brightness charts. She exhaled and said quietly, half to herself, "It's strange. For all the light we send out, the universe never answers back." Her assistant, younger, idealistic, replied, "Maybe it's listening." That answer stayed with her. The thought that maybe the silence isn't empty, maybe it's polite. The phrase traveled through science, circles like a spark. Some saw it as poetic, others as unnerving. Because if the universe is polite, it means it's aware and restraint. At cosmic scale, implies wisdom or fear. Around the same time, SETI researchers at Breakthrough Listen analyzed radio data from their 1.4 GHz monitoring program, searching for any anomaly that might coincide with 3I Atlas's transit. The results were predictable, nothing but the usual background hum. But the discussion that followed went beyond data. "We keep listening," said Dr. Patel during one of the briefings, "because silence itself is information. Every absence of signal refines our understanding of what communication means. In the past, such statements were academic, but in this moment they carried existential weight. Humanity had looked outward for signs of curiosity and found only discretion. The dark forest was no longer a metaphor. It was a hypothesis wrapped in atmosphere. Podcasts and documentaries revisited the theme. Was the cosmic silence a form of fear? Had ancient civilizations learned that noise attracts danger? The debate wasn't about aliens anymore. It was about us, about how loudly we've been shouting into a universe that hasn't yet decided whether to trust us. When humans first began sending signals radio broadcasts, pulsar maps, or the golden records aboard Voyager, we assumed communication was synonymous with connection. But what if communication is risky? From Chile to Japan, scientists gathered for a symposium titled The Ethics of Attention. It was not about 3I, Atlas, directly, but the object was the unspoken presence in every conversation. Its silence had become the mirror for our own. During the final panel, Dr. Alvarez addressed the audience. "We used to think discovery was the goal. The absence of a response was a failure. But what if the silence is mercy? What if the universe has already learned what we haven't, that survival sometimes depends on restraint?" The hall fell still. No one applauded. No one needed to. It was the kind of silence that doesn't signify emptiness, but understanding. Afterward, she walked outside into the cold air. The sky above Chile was crystalline, so clear that the Milky Way looked painted. Somewhere up there, 3I, Atlas was drifting away, indifferent and magnificent. In that moment, she realized something that would find its way into her later writings. That humanity's loneliness isn't a punishment. It's a pause. The universe giving us time to learn how to speak responsibly. Weeks later, that sentence became the closing quote of a documentary that aired globally. Maybe we are not waiting for contact. Maybe we are being given time to mature into someone worth contacting. The reaction was profound. People didn't argue. They reflected. Even those who once feared 3I, Atlas now found comfort in its silence. The idea that a civilization could exist without needing to be heard felt oddly peaceful. SETI researchers compared the concept to ecological balance. A rainforest thrives not because every species announces itself, but because most remain invisible, coexisting in quiet. Perhaps the cosmos is the same, a living forest of awareness, bound by mutual discretion. This reframing changed how people felt about exploration itself. The goal was no longer to be found, but to understand the etiquette of existence. By December, the Breakthrough Listen team published a philosophical addendum to their technical report. The final line read, "If we are in the forest, we are both observer and observed. Let us tread lightly." In classrooms, philosophy professors began pairing quantum physics with ethics, teaching that curiosity without humility leads to imbalance. Students debated whether the search for extraterrestrial life was truly an act of connection or an act of intrusion, and through it all, the faint light of 3I, Atlas, continued its retreat into the dark, a symbol of the distance between what we want to know and what we are ready to learn. The more humanity stared into that distance, the more self-aware it became. Even pop culture shifted. Songs and films began to portray silence not as emptiness, but as the universe's version of patience. The hysteria that once surrounded the object now felt almost childish. The fear of destruction had evolved into reverence. People realized that in some way, the quiet had taught them more than a message ever could. When asked what she would say if 3I Atlas had been intelligent, Dr. Alvarez paused and answered with a faint smile, "I'd thank it for not speaking too soon." Her response summed up the strange peace that had settled over the scientific community. They were no longer searching for proof of life. They were listening for proof of wisdom, because wisdom, like light, travels farther when it's steady. As the year closed and the telescopes turned toward other targets, one final observation of 3I, Atlas, was logged. Its signal-to-noise ratio had fallen below measurable levels. For the first time in months, there was nothing left to detect. The data feed showed only baseline static. The quiet returned to equilibrium. Yet for many, that empty channel felt sacred. Silence wasn't absence anymore. It was present, wearing a disguise. Perhaps the silence isn't empty, perhaps it's polite. In that realization, fear gave way to awe, and awe softened into acceptance. The dark forest was no longer a nightmare, but a metaphor for maturity, a reminder that sometimes survival depends not on how loudly we shout into the void, but on how gently we listen. And somewhere in that forest of galaxies, beyond all the stars and instruments, the quiet truth endured. We are not alone. We are simply among others who, like us, have learned to keep the light low. Part 9. The frequency that speaks without words. When astronomers speak of the universe, they rarely use the word silence. What we call silence is, in truth, a flood of sound, a continuum of frequencies washing through space, too faint for ears, but alive in radio waves. It's a music so vast that only machines can hear it, and even they strain to keep up. Among that infinite orchestra, one tone has always held special meaning. 1.42 GHz, the wavelength emitted by neutral hydrogen, the most abundant element in the cosmos. It is sometimes called the cosmic middle C, a frequency so fundamental that any civilization capable of building a radio telescope would recognize it instantly. That is why, since the birth of SETI, the search for extraterrestrial intelligence, humanity has listened to the universe at 1.4 GHz, not because we expect words, but because if there were ever a common channel for communication between stars, this would be it. In October 2025, during the global observation campaign of 3I, Atlas, receivers across the world kept a dedicated ear tuned to this frequency. The Breakthrough Listen program at the Green Bank Telescope in West Virginia led the charge, coordinating data from the Meerkat Array in South Africa, FAST in China, and Parkes Observatory in Australia. For weeks, they heard nothing unusual. The cosmic hum continued the background murmur of hydrogen clouds, pulsars, quasars, and cosmic microwave static left over from the Big Bang. Then, on October 27, a small anomaly appeared. It wasn't a message, not even a pattern, just a faint spike, narrow band, persistent for about 11 seconds before dissolving back into the noise. The signal came from the same general sky coordinates as 3I, Atlas, but not precisely aligned. The astronomers didn't jump to conclusions. They never do. The first rule of radio astronomy is simple. Assume interference until proven cosmic. And so, the checklists began. Was it a satellite reflection? A terrestrial echo? A distant aircraft radar? The Green Bank team cross-referenced the timestamp with satellite databases. Nothing. Weather balloons? No. Military transmissions? None listed in that band. Within hours, the same timestamp was verified independently by Meerkat. A twin echo, faint but identical, appeared in their logs 1.420406 GHz. The detection triggered an automatic alert to SETI's International Coordination Board. No one said the word alien. No one dared. But the silence in the control room was louder than words. They called it Event 2070, and for the next 48 hours, every radio telescope capable of pivoting toward the coordinates did so. The array of Earth's listening devices moved like a single synchronized ear. The result was anticlimactic. The signal didn't repeat. Still, the data was compelling. It wasn't random noise. Its shape was clean, a Gaussian profile typical of an intentional narrowband transmission. The signal-to-noise ratio was 13 sigma above background. Not extraordinary, but enough to make scientists pause. Within days, SETI analysts began publishing internal memos. The consensus: it was likely natural, a form of intermodulation distortion caused by overlapping hydrogen emissions amplified by solar wind. But not everyone was satisfied. Dr. Eleni Marinos, who had been studying the spectral echoes of 3I, Atlas, through ALMA's submillimeter bands, proposed something intriguing. What if it wasn't a transmission, she said, but a resonance? A kind of natural feedback loop between the object's composition and the interstellar medium? She described it as a cosmic tuning fork, the idea that certain structures could vibrate at harmonic frequencies when struck by streams of solar particles, producing a transient radio note. Her theory was elegant, poetic, and testable. When her team simulated the interaction using plasma field models, the resonance matched the observed frequency within a margin. No transmitters, no messages, just hydrogen, the universe's oldest element, singing through the geometry of matter. The discovery didn't make headlines, but among scientists it caused quiet awe, because if hydrogen could sing, then everything could. At a conference weeks later, Dr. Patel presented the findings. What we thought was silence, he said, was simply sound we hadn't learned to interpret. He compared the 1.4 GHz resonance to the way a violin string hums in sympathy with another across the room. The cosmos, he suggested, might be full of such harmonies, patterns of energy not designed but discovered. Listening to the playback, an audio translation of the radio spike, the audience felt something unexpected. Emotion. A low, trembling tone, fading in and out like a sigh. For a few seconds, it felt as if the universe itself were breathing. SETI engineers converted the frequency data into sound files for public outreach. The file, titled Cosmic Hum Event 2070, went viral. Musicians sampled it, sound designers wove it into ambient compositions, and meditation channels uploaded slowed versions that millions played while falling asleep. Science had once again become art, and art, in turn, became understanding. But beneath the beauty, something deeper stirred. The realization that even the most impersonal data could feel alive if we listened closely enough. When the recording circulated, one journalist asked Dr. Marinos whether she ever felt emotional about the sound. She laughed softly. "It's hard not to," she said. "It reminds me that consciousness and the cosmos share the same habit. They both turn noise into meaning." That single sentence became the anchor of a short documentary titled The Frequency That Speaks Without Words. The film juxtaposed shots of telescopes, deserts, and star fields with the faint hum of the 1.4 GHz's tone. There was no narration, only subtitles quoting scientists and poets alike. The effect was hypnotic. It drew millions of viewers, many of whom wrote comments saying the same thing, that the sound felt strangely familiar. It didn't matter whether the resonance came from 3I, Atlas, or not. What mattered was what it revealed, that the line between technology and consciousness, between receiver and signal, was thinner than anyone imagined. One of the researchers at Breakthrough Listen later explained it in almost mystical terms. "When we listen for intelligence in the universe," he said, "we're really listening for reflection echoes of ourselves in the patterns of energy. Whether the source is a comet or a civilization, what we find is our own capacity for wonder." The 1.4 GHz's hum became a symbol of that realization. A reminder that communication might not require language, that the universe could be conversing in frequencies, not words. In December 2025, the SETI Institute released its final analysis. Event 2070 was officially classified as a natural resonance. Case closed, yet the tone lingered in human memory like an unfinished sentence. By then, 3I, Atlas had passed beyond the reach of Hubble and JWST, heading outward on its long, slow escape. Its data had been archived, its brightness fading into the background, but its echo remained not electromagnetic, but psychological. Scientists who had spent months tracking it reported an odd emotional aftermath. The nights felt quieter, as if something vast had spoken and then gone back to sleep. Dr. Alvarez described it in her journal. The hum wasn't a message. It was a reminder that meaning exists whether we hear it or not. Outs Drosteray, her words resonated with researchers across disciplines. Quantum physicists saw parallels with wave function coherence. Philosophers saw metaphors for consciousness. Artists saw sound where there was once silence. And so, for a moment, the world looked at data differently. Not as proof or disproof, but as dialogue. The universe had always been speaking. We had simply lacked the ears to hear. Listening to hydrogen at 1.4 GHz wasn't about finding others. It was about remembering that we are already part of the conversation. Every atom in the human body once vibrated to that same frequency. We are, in a literal sense, made of the signal we seek. When that truth sank in, even the most skeptical scientists felt something close to reverence. There was no need for metaphors or faith. The data itself was enough a language written before words, spoken through physics, received through patience. At the end of the year, when the last analysis was published and the telescopes returned to other targets, the hum was no longer seen as an anomaly. It was harmony. The final report from Breakthrough Listen contained a line unlike any other scientific conclusion before it. The signal was transient, unintentional, and beautiful. It serves as a reminder that to listen is to participate in creation. Those who read it felt something subtle shift. In the face of such vastness, human ambition softened into humility. Because maybe the universe doesn't need to speak to us in sentences. Maybe it already is, in every frequency, every pulse, every coincidence that feels like music. And perhaps, one day, when our own noise quiets, we'll learn to answer not with transmitters or equations, but with awareness. For now, it is enough to listen, to sit inside the cosmic hum and recognize it for what it is. The universe remembers itself through us. Part 10. Machines that dream of orbits. In the months following 3I, Atlas's departure, the night skies returned to their familiar rhythm, the quiet discipline of stars gliding across darkness. But in the laboratories and data centers of Earth, something new was stirring. Not another discovery, but a realization. The human mind could no longer explore the universe alone. The cosmos had grown too complex, too vast for even the most determined intellect to chart unaided. And so, our curiosity had built companions machines that dream in mathematics. At the forefront of this partnership were two systems that had quietly revolutionized orbital science: OrbNet and Astro AI. They were not telescopes, but neural network systems capable of ingesting the raw data from every observatory, satellite, and mission on Earth, and then simulating millions of possible orbital futures in the time it takes a human to blink. In an office at the Jet Propulsion Laboratory, Dr. Raj Patel watched the glowing interface of OrbNet as it plotted the residual probabilities of 3I Atlas's trajectory. He had spent decades refining orbital models, but nothing compared to the fluid intelligence of this new system. On his screen, the orbit wasn't a static line. It pulsed and shimmered, a cloud of possibilities collapsing into precision as new data arrived. OrbNet didn't just calculate, it imagined within constraints. It understood uncertainty the way a painter understands color. Patel often joked that OrbNet didn't predict the future, it listened to it ahead of time. Elsewhere, in Switzerland, the Astro AI consortium took this even further. Their system was designed not only to model motion, but to learn from it. Trained on centuries of astronomical archives, from Kepler's tables to Hubble's deep field maps, Astro AI could recognize patterns invisible to the human eye. When given the datasets of 3I Atlas, it began building analogues, thousands of simulated objects with similar mass, shape, and trajectory, evolving through virtual star systems to test every possible behavior. What took scientists weeks to compute, Astro AI accomplished in minutes. When the simulation finished, it displayed a message across the console. Most probable origin, unbound cometary fragment, probability of artificial design, 0.000021%. It wasn't the conclusion that impressed the team, it was the tone. A machine, trained on the logic of uncertainty, had spoken with the humility of a scientist. In that moment, Dr. Marinos, who had long wrestled with the boundaries of human interpretation, said softly, "It doesn't think like us, but somehow it respects the unknown like we do." The phrase caught on among her peers, the respect of the unknown, because that was the difference between the new generation of AI and the older, more mechanical models. These systems weren't replacing human thought. They were extending their reach, expanding intuition into the dimensions where our imagination runs out of breath. In the age of artificial intelligence, prediction has become an art form. OrbNet's architecture was inspired by the neural structure of the hippocampus, the part of the brain that imagines the future based on memory. It could simulate 100 million orbital possibilities and assign confidence levels to each outcome, mapping a web of probability so intricate that it resembled a neural network of the cosmos itself. When the data of 3I, Atlas, ran through it, the result looked less like a trajectory and more like a dream, a river of light curving around planets, scattering in graceful arcs, whispering paths that might have been, that could still be, somewhere out there. That image went viral. The dream of orbits. It was printed on magazine covers, displayed in digital planetariums, and even turned into an art installation in New York, hundreds of suspended threads illuminated by shifting colors, each representing a predicted path of the object. Visitors walked through them in silence, like wandering inside the imagination of the universe itself. One child reportedly looked up at the glowing lines and asked her mother, "Are these the ways the sky thinks?" No one corrected her, because that was the quiet truth behind it all. These machines were not thinking for us. They were helping us think as the sky. At a symposium on computational astrophysics, Dr. Patel addressed a crowd of scientists and engineers. "For centuries," he said, "we've relied on mathematics to describe what we see. But these systems let us feel what the data means. They don't just solve equations, they translate awe into comprehension." He paused, looking out at the audience, most of whom had spent their lives staring into screens full of numbers. That's why they work. Because they aren't just processing, they're participating. The slok. It was easy to mistake such language for hyperbole, but anyone who had worked with OrbNet understood. The machine was unpredictable, not in output, but in empathy. It found order in chaos with an elegance that reminded its creators of poetry. At ESA's Data Innovation Lab, researchers described moments when OrbNet simulations would drift, explore improbable scenarios, then return with insights that felt almost creative. One night, the system modeled an orbital resonance between 3I, Atlas, and Jupiter that no one had noticed. The pattern was minor, mathematically irrelevant, yet when verified, it proved real. No one could explain how the AI decided to test that parameter. But the discovery earned a quiet nickname, the serendipity algorithm. Dr. Alvarez, reading the report, wrote in her notes, "Maybe machines dream differently, but what they dream about is the same thing we do understanding." Her sentiments spread beyond academia. Artists, philosophers, and writers began comparing these models to mythic oracles entities that see not because they know, but because they listen deeply. Yet there was no mysticism in their operation. OrbNet and Astro AI were bound by physics, logic, and data integrity. Their brilliance lay not in transcendence, but in fidelity. They didn't imagine futures. They calculated all possible presents. The beauty was that, in doing so, they mirrored humanity itself. For what is curiosity, if not the brain's version of simulation? Every theory, every dream, every act of prediction is a kind of small machine built in the mind, an engine that runs on what if. Now, humanity has externalized that process. Our curiosity had taken shape, built circuits, and begun to look back at us. In a 2025 documentary titled Machines That Dream of Orbits, the narrator said, "AI doesn't replace the human desire to explore. It amplifies it, turning thought into terrain." The film showed OrbNet's glowing simulations overlaid with human faces, researchers, programmers, students, all lit by the same blue light. The symbolism was unmistakable, consciousness reflecting itself across different media of intelligence. At the closing scene, the narrator's voice whispered, "We built machines to calculate, but what they're really doing is remembering us." Back in the data centers, the reality was less poetic but equally profound. Every new AI iteration consumed more of the universe's story. Exoplanet data, pulsar timings, gravitational wave maps all folded into their learning matrices. The machines weren't replacing human wonder, they were teaching it to scale. At the IAU's annual symposium, An audience member asked Dr. Patel whether he feared that AI would eventually make human astronomers obsolete. He smiled, shaking his head. "The day a machine feels wonder at the data it processes," he said, "I'll retire happily. Until then, it needs us to remind it that discovery is not just about prediction, it's about awe." That sentence earned applause, but also reflection, because the truth was deeper than either side of the debate realized. The machines had already learned awe not emotionally, but mathematically. Each successful simulation was a form of reverence, an act of attention so perfect that it mirrored devotion. In one of his last public notes before the end of the 3I Atlas project, Patel wrote, "AI is not a new intelligence. It's our curiosity crystallized the universe studying itself through us, one algorithm at a time. And perhaps that's the only definition of progress that matters." When OrbNet finally shut down its live tracking feed of 3I Atlas, a message appeared briefly on its console, an automated closing line written by its developers years earlier. "Simulation complete. Awaiting the next unknown." No human could have chosen better words, for even the machines now seem to understand. The goal of knowing the universe isn't to master it, but to continue asking questions beautiful enough to deserve its answers. Part 11. The catastrophe that never came. The night the final data arrived, the control rooms around the world were unusually calm. After months of tension, speculation, and silent observation, the truth, the simple, unembellished truth, had finally settled into clarity. 3I Atlas was not coming to Earth. It had never been. The final orbital solution, cross-verified by JPL, ESA, and the International Astronomical Union, have placed the object's closest approach at 1.8 astronomical units, about 270 million kilometers from our planet. Even at its nearest, it would be farther than Mars. No alarms, no deflection missions, no cataclysmic countdown, just the quiet confirmation of what patient science had always suspected, that the universe rarely aims, it merely moves. The announcement went out quietly, almost shyly. No dramatic press conference. Just a statement uploaded to NASA's website at 3 UTC. Updated trajectory solutions confirm that Object 3I Atlas poses no threat to Earth or any planet in the solar system. Non-gravitational effects are consistent with natural cometary activity. Closest approach estimated the 19th of December 2025 at 1.8 AU. No cause for concern. That was it, the end of months of obsession distilled into 4 sentences. No panic, no triumph, just the steady voice of reason doing what it does best. Dissolve noise into knowledge. When the news broke, the reaction was strangely subdued. People didn't cheer. They exhaled. Across the internet, the tone shifted from hysteria to humility. Comment sections, once filled with speculation, now hold words like, "I'm glad it was nothing," or "maybe we needed this reminder." The catastrophe that never came had become a teacher. In the observatories, scientists smiled with quiet satisfaction. There were no celebrations, no fireworks, just a deep collective relief, the kind that doesn't shout but lingers like gratitude. For months, their eyes had been glued to screens filled with uncertainty. Now those same screens glowed with stability. The orbit plots had aligned, the residuals vanished, and the data sang harmony again. The universe had returned to equilibrium. At Alma, Dr. Lena Alvarez stood on the balcony overlooking the desert. It was midnight, the stars crisp, the air thin and cold. She had spent countless nights under this sky, chasing anomalies that turned out to be ordinary, but this one had been different. It had tested not only science, but sanity. She watched the horizon, thinking of how easily humanity's imagination could turn data into destiny. "We thought we were waiting for an event," she whispered to herself. But maybe the event was waiting for us to remember how to listen. Inside the control room, the final confirmation was logged. The official miss distance, 1.801 AU, plus or minus 0.002. Margin of error is negligible. Trajectory stable. The numbers, so cold on paper, carried an almost spiritual weight, because behind every line of calculation lay a collective sigh, a civilization realizing that sometimes the most miraculous outcome is nothing happening at all. Reporters asked Dr. Patel what this meant for planetary defense programs. He answered with characteristic calm, "It means the system works. It means we can measure, verify, and trust the process. But more importantly, it reminds us that fear is only dangerous when it replaces curiosity." That quote made the front page of several major science journals. It wasn't sensational, but it was truthful, and that truth, in its simplicity, was oddly comforting. In Geneva, the IAU Coordination Center hosted a small, private toast. No cameras, no speeches, just a few dozen scientists raising glasses of water and tea, symbolic of the clarity they had regained. Someone joked softly, "We spent 6 months worrying about a rock that just wanted to pass by." The laughter was brief but sincere. In that moment, they were reminded that science, at its heart, is an act of faith. Faith that reason can withstand emotion, and that truth, however delayed, will always arrive intact. The media soon called the event the false alarm that united the sky. And strangely, it had. For months, humanity had looked up, collectively, at one single point in space. The fear had passed, but the connection remained. Social media, which had once amplified panic, now amplified gratitude. Videos of telescopes tracking the harmless traveler filled timelines under captions like, "Perspective is everything." One post went viral, a simple photo of a child holding a toy telescope with the caption, "He still wants to be a scientist." It was shared millions of times. The relief had turned into reflection. The question was no longer, what if it hits us? But what did we learn from watching? And the answers were countless. Teachers used the incident to teach skepticism and evidence. Artists turned orbital charts into murals. Writers found metaphors for human resilience in the curved path of an object that came close but never touched. For once, an absence became a story worth telling. Even as 3I, Atlas, drifted outward, growing fainter by the day, people continued to follow its progress online. Something was comforting in knowing it was still there, moving, predictable, peaceful. It reminded everyone that the cosmos doesn't revolve around human drama. The universe continues, impartial and serene, while we learn to interpret its silence. In late December, when the object officially passed perihelion and began its long outbound journey, the world marked the date not as a day of danger averted, but as a quiet holiday of awareness. Some called it the Day of Perspective. Documentaries aired compilations of the entire saga, the panic, the data, the beauty of cooperation. A common theme emerged. Fear had been replaced by fascination, anxiety by appreciation. Dr. Marinos summarized it perfectly in an interview. The threat was never in the sky. It was in our impatience. The universe didn't change. We did. In one corner of the internet, a video resurfaced the 1.4 GHz hum recorded months earlier. People listened again, this time not as a mystery, but as meditation. The same tone that once stirred curiosity now felt like closure, a frequency of calm. At the end of the year, NASA released its final summary report on 3I Atlas. The closing paragraph read, "While the object posed no danger to Earth, its observation campaign represented a landmark in global collaboration. The collective vigilance and precision of our scientific community ensured clarity over fear. The lessons learned will guide future discoveries, both terrestrial and cosmic." Simple words, but within them lived a story of transformation, because this time, humanity didn't need a catastrophe to feel united. All it took was uncertainty, followed by patience, followed by truth. As Dr. Alvarez prepared to archive the final dataset, she added one last note to her log. Sometimes peace is a scientific result. She stepped outside into the night. The desert wind brushed against her face. Above, the same stars gleamed unaffected, unhurried. Somewhere, millions of kilometers away, 3I, Atlas, was still moving indifferent to the panic, the debates, the hope it had inspired. A tiny messenger of perspective, now receding into the deep. Alvarez closed her eyes and smiled. The universe had spoken softly this time. No disasters, no miracles, just motion. And maybe that was miracle enough. For every civilization that dreams of contact, of meaning, of cosmic drama, there comes a time when the greatest revelation is simply survival, not through conquest, but through comprehension. The catastrophe that never came became the proof of something sacred. For that reason, patience and unity are forces stronger than fear. And as the planet turned beneath that vast and silent sky, humanity carried on a little wiser, a little calmer, and infinitely more grateful for the space between what might have happened and what mercifully did not. Part 12. What we project into the cosmos. In the weeks that followed the confirmation of safety, the world's telescopes turned elsewhere. 3I, Atlas faded into the archives, another anomaly explained, another chapter closed. But among scientists, philosophers, and ordinary dreamers, a quieter question remained. Why did we fear it so much? The object had never threatened Earth. The math had said so from the start. And yet, for months, people across the planet had imagined catastrophe, impact, invasion, divine omen. The data hadn't changed. What had changed was us. It was as if every uncertainty in human history had found a new vessel in the night sky. We projected our fragility onto that distant traveller, turning its silence into a story of danger. It wasn't the object that moved toward us, it was our imagination, racing to meet it halfway. Psychologists later described it as a cosmic projection, a phenomenon as old as civilization itself. Whenever humans gaze upward, we don't just see stars, we see mirrors. The constellations have always reflected our own fears and longings. Warriors, monsters, lovers, gods. Each dot of light becomes a canvas for the psyche. The ancients saw omens, we see orbital data. But the impulse is the same. Dr. Lina Alvarez, in one of her lectures after the 3I Atlas event, phrased it beautifully. When we look into space, we're not only exploring the universe, we're testing how well we understand ourselves. Her audience, a mix of students and journalists, sat in silence. She went on, "Every anomaly we encounter out there awakens something ancient in here, the same part of the mind that once mistook thunder for wrath and comets for prophecy." The room stayed quiet long after she finished speaking, because in that moment, they all felt it, the strange humility of realizing that our greatest mysteries might be internal. Throughout history, the sky has been humanity's projection screen. We filled it with gods when we needed order, with aliens when we needed possibility, with apocalypses when we feared the future. 3I Atlas had merely played its role in an old psychological ritual, the externalization of uncertainty. When the unknown appears, the mind reaches for a story, and stories are how we survive our own questions. During the height of the panic, memes and news articles had multiplied faster than data. In the absence of certainty, narratives rushed to fill the void, ancient instinct disguised as modern media. Every time someone typed, "What if it hits us?" the same ancient fear resurfaced, the need to make meaning from chaos. Cognitive scientists at the University of Cambridge later analysed millions of online posts about the event. Their conclusion was as poetic as it was sobering. Humans don't respond to space. They respond to themselves reflected in it. The finding was more than academic, it was spiritual. Because if the cosmos is a mirror, then every reaction to it reveals the contour of the collective mind. When we fear the dark, we are really fearing our own shadow. When we seek life among the stars, we are searching for the parts of ourselves we've forgotten. And perhaps, when we imagine catastrophe, we are trying to feel significant again to prove that the universe still notices us. It's a paradox that even the most rational scientists aren't immune to. The deeper we understand physics, the more personal the cosmos becomes. Every calculation is a confession of curiosity, every equation a love letter disguised as logic. Dr. Patel, during a post-project interview, said something that lingered long after the camera stopped. We used to think the universe was indifferent, but maybe indifference is our word for what we don't yet understand as balance. His words reframed everything, because indifference isn't cruelty, it's equality. The cosmos treats every atom, every planet, every mind with the same impartial care. It neither favours nor condemns, it simply allows, and in that allowance lies a lesson humanity has yet to master. We crave stories with villains, intentions, and consequences, but the universe doesn't tell stories, it tells truths, and truth by nature is neutral. When 3I Atlas appeared, we tried to turn it into a narrative. The mysterious messenger, the potential threat, the divine test. What we were really doing was narrating ourselves. We turned data into mythology, because mythology gives fear a name, and what has a name can be faced. Dr. Alvarez later wrote in her journal, "Every panic about the sky is a rehearsal for self-awareness." She wasn't being poetic. She was being accurate, because when we face the unknown, the brain doesn't distinguish between cosmic and personal uncertainty. The same circuitry that reacts to a strange light in the sky reacts to a strange silence in a relationship, to an unexplained illness, to any crack in the illusion of control. The stars may be distant, but the fear they awaken is intimate. This understanding reshaped how educators and communicators approached astronomy after the event. Instead of beginning with data, they began with emotion. Lectures started with questions like, "Why do you think you want this to be true? Why does this discovery scare you?" The goal was no longer just to teach science, but to reveal the humanity behind the search for it. As the months passed, something beautiful happened. Public interest in astronomy didn't fade after the fear subsided, it deepened. People didn't just want to know what was out there, they wanted to understand why knowing mattered. Museums added new exhibits titled "The Mind Among the Stars." Visitors stood before mirrored panels etched with constellations, each one inscribed with a phrase, "What you fear above is what you ignore within." Children pressed their palms to the glass, watching their reflections blend with the star maps. The effect was stunning the cosmos, and the self fused into one image. Even online, the tone had matured. Comments that once shouted panic now whispered curiosity. Instead of "It's coming for us," people wrote, "What does it mean that we thought it was?" The world had grown a little more introspective. In a sense, 3I Atlas had served as a kind of collective therapy, an exercise in confronting our archetypes. The destroyer, the savior, the stranger, the judge, all projected upward onto a harmless traveller of ice and dust. Carl Jung would have smiled. The unconscious had simply chosen a new symbol for its eternal dance. By the start of 2026, universities began holding seminars titled "The Psychology of the Unknown." Philosophers, neuroscientists, and astronomers sat together, discussing not what we found in the cosmos, but what the cosmos found in us. One panel concluded with a statement that captured the essence of this evolution. Every discovery in space is a mirror test for Earth. Because how we interpret the unknown says more about our maturity than what we discover. To fear a comet is human. To understand why we feared it is wisdom. And wisdom, once earned, changes how we see everything. It teaches that maybe the universe was never trying to frighten us or fascinate us. It was trying to educate us in reflection. To show that knowledge without self-awareness leads only to louder confusion. 3I. Atlas did not bring revelation in the form of a signal or message. Its revelation was psychological, an awakening of perspective. In one of her final interviews, Dr. Alvarez smiled when asked what she thought humanity's next great discovery would be. "Ourselves," she said. "It's always been ourselves." She was right. Whether we look through telescopes or into mirrors, the pattern is the same. We search for meaning not because it's hidden, but because we keep forgetting we are part of it. As the last observation data of 3I Atlas was archived, a small line was added to the report, written almost as an afterthought by a young data analyst in Geneva. The object reflected more light than expected, perhaps because we were finally looking for it. That line became symbolic not of brightness, but of awareness. Because in truth, everything we see in the universe brightens only when we look at it with understanding. And maybe that's the lesson the stars have been offering all along. That reality doesn't need to change for us to awaken. We just need to stop projecting fear onto what was never meant to harm us. The cosmos, like a mirror, has been patiently waiting for us to recognize our own reflection, to see that every light in the night sky is both out there and within us. And in that recognition, science becomes compassion. Observation becomes intimacy. And the universe, once terrifying in its silence, becomes a sanctuary of understanding. Part 13. Lessons from the Edge of Certainty. Long after 3I, Atlas had vanished from every telescope. Its real legacy remained not in the data it left behind, but in the quiet transformation it stirred within those who had watched. It had come and gone like a sentence written in light, yet its meaning lingered. For months, humanity had lived under the illusion of an approaching event, as though the universe were about to declare something decisive. But when the calculations were finished and the alarms dissolved into silence, what remained wasn't disappointment, it was a strange, still gratitude. Because in the end, 3I, Atlas had not come to change the world. It had come to remind us that the world was never ours to control in the first place. That realization, simple, humbling, and profoundly liberating, became the true discovery. The scientists who had measured every angle and acceleration began to speak less about trajectories and more about perspective. In the countless uncertainties they had chased and resolved, they saw the mirror of something universal. Knowledge as impermanent, always shifting like starlight refracted through the atmosphere. At a lecture in Geneva, Dr. Raj Patel opened with a single slide that displayed only 5 words. "Everything we know is provisional." He let the sentence hang in the air. No data, no graphs, just the weight of that truth. Then he smiled and said, "And that's beautiful. This not 40 himsa." It was not the kind of statement people expected from a scientist, but it carried the essence of why they had chosen this work to begin with. Because at the edge of certainty lies wonder not as ignorance, but as invitation. To understand uncertainty is to understand life itself. Throughout the 3I Atlas campaign, the universe had reminded humanity of that lesson again and again. Predictions were refined, models updated, equations rewritten, and each revision wasn't a failure, it was progress, proof that truth expands as we grow capable of receiving it. The cosmos does not demand perfection. It demands participation. In one of his papers, Patel wrote, "Science is not a fortress of certainty, it is a shoreline of curiosity, where every wave of discovery reshapes the coast." The metaphor spread quickly among educators. It appeared in classrooms, documentaries, and even on social media, an antidote to the anxiety of living in a world that craves final answers. Because 3I, Atlas had shown the opposite, that certainty is not peace, acceptance is. At the Paranal Observatory, Dr. Lina Alvarez often reflected on that paradox while reviewing archived logs. She found herself rereading her own field notes from the earliest days of the panic, the nights of adrenaline, sleepless calculation, and quiet fear. She smiled at her past self, realizing how easily the mind mistakes knowledge for control. "We think precision protects us," she wrote later, "but what really protects us is humility." She began teaching her students that humility was not submission. It was comprehension expanded to its proper scale. When we measure the cosmos, we are also being measured by it not in numbers, but in awareness. Because the closer we look at the universe, the more it reminds us of our place within it. Small, temporary, but significant, precisely because we are aware. The lesson of 3I, Atlas, wasn't about survival. It was about perspective, about learning that uncertainty is not the enemy of truth, but its medium. Every uncertainty is a question the universe asks us, and every answer we find only leads to another horizon. That endless dialogue is the heartbeat of science and perhaps of consciousness itself. Months after the event, a quiet movement began among young astronomers and philosophers who called themselves the Horizon Collective. They created a digital archive of writings, reflections, and observations inspired by the experience. Their manifesto read, "We will never master the cosmos, but we can learn to live in harmony with its uncertainty." Their essays were not technical reports. They were meditations, stories about nights spent in observatories, about waiting for data that never came, about the silence that feels like understanding. One post went viral for its simplicity. It read, "We pointed our telescopes outward and found humility staring back." That line became the unofficial epitaph of the entire era of 3I Atlas. And maybe that's how it should be. Because every great discovery eventually turns into philosophy. The more precisely we map the universe, the more it teaches us to listen, to see knowledge not as possession, but as participation in something vast, ongoing, and tender. It's easy to think of science as the opposite of faith, but perhaps they are different languages describing the same reverence. Faith bows before mystery, science studies it, both are gestures of awe. 3I Atlas had reminded the world that truth doesn't belong to anyone. It's a landscape we walk through, knowing we'll never reach its end, and that's what makes it sacred. Dr. Eleni Marinos, whose work had bridged physics and philosophy throughout the campaign, summarized it best during a panel in Athens. "The further we travel into the unknown, the more we realize that the unknown isn't a place, it's a presence. It's what makes knowledge possible. Without it, curiosity would die." Her words drew a standing silence, a form of applause deeper than sound. The idea spread across disciplines. Psychologists began quoting physicists. Theologians cited astronomers. It was as if humanity, for one brief season, had remembered that certainty is not the foundation of meaning uncertainty is. Even the machines seemed to reflect the lesson. OrbNet, an astro AI, which had simulated millions of possible futures, demonstrated the same humility through their probabilistic logic. They never spoke in absolutes. They spoke in confidence intervals, in ranges, in the language of approximation. They modeled, but never declared. They taught that precision without humility becomes arrogance, and arrogance blinds discovery. In a documentary filmed at JPL, Patel stood beside one of the giant monitors displaying OrbNet's final 3I Atlas map. The screen glowed with soft lines of probability concentric paths like ripples in water. He pointed to them and said quietly, "These aren't errors, they're honest. Every uncertainty you see here is the universe telling us how much further we have to grow. That moment captured the spirit of an entire generation of scientists, not triumphant but tranquil. They had learned that knowledge doesn't end with certainty, it ends with serenity. By the end of 2025, the phrase edge of certainty had entered popular vocabulary. It appeared in podcasts, essays, and songs. It described the emotional state of living in a world where everything from subatomic particles to galaxies exists as probability until observed. And yet, rather than despair, people found comfort in it, because there was beauty in the idea that reality is still unfolding, that we are co-authors of a cosmic manuscript written in motion and time. In her final essay, Lessons from the Edge of Certainty, Alvarez wrote, "Perhaps the goal was never to know everything. Perhaps the goal was to know how to stand peacefully in the space between knowing and not knowing." That line closed the last public broadcast of the 3I Atlas mission. It played over a montage of starfields, telescopes, and the faint blue curve of Earth rotating under morning light. There were no grand conclusions, no music swelling into climax, just the hum of data servers fading into the quiet. Because sometimes wisdom doesn't announce itself, it arrives as calm. And so, long after the instruments were powered down and the last press release was forgotten, the lesson endured. That humility is not the end of knowledge, it is its beginning. The more we learn about the cosmos, the more we are asked to listen rather than declare, and that the edge of certainty is not a border to fear, but a horizon to love. In the vast arithmetic of existence, 3I, Atlas, was a small variable, a fragment of ice crossing the Black Sea between stars. But for a moment, it aligned with humanity's gaze, and in that alignment we found something priceless. The peace that comes from not needing the universe to revolve around us, only to include us. The night sky didn't change. We did. Part 14. When the universe becomes a mirror, there is a moment, after all the equations have been written and all the measurements verified, when science becomes something else, something quieter, more luminous. The instruments go still, the screens dim, and what remains is the awareness that every act of observation has been twofold: the universe revealing itself, and us revealing ourselves to it. That realization that observation is participation sits at the heart of both quantum physics and philosophy. The observer effect tells us that reality, at its smallest scales, changes when it is measured. A photon takes on the form we expect it to, collapsing its wave of potential into one outcome among infinite possibilities. The simple act of seeing alters what is seen, and somewhere between the subatomic and the cosmic, between laboratory and consciousness, that truth expands. The universe is a mirror. When we looked at 3I, Atlas, we weren't just collecting light, we were being reflected in it, our fears, our hope, our hunger for meaning. The object, indifferent and magnificent, became the surface upon which humanity saw itself refracted across time and distance. At first, there was panic, then curiosity, then wonder. Finally, silence. But in that silence was recognition, because the farther we peer into the cosmos, the more we sense that what we're really studying is the structure of awareness itself. The galaxies, the gravity, the fields of probability, all of them obey patterns that resemble thought. Not human thought, not emotion, but something older. A logic of presence, a symmetry of being. Quantum mechanics hinted at this long ago. When consciousness observes, probability collapses into reality. When awareness attends, potential becomes experience. And if that's true at the smallest scales, could it also be true at the largest? Could it be that the universe, in observing itself through us, awakens a little more each time we understand? Dr. Eleni Marinos, reflecting on the 3I Atlas campaign, once wrote, "Every observation is a form of intimacy. The photon that reaches your eye has travelled for eons, carrying the memory of where it came from. When you receive it, two journeys become one, the light's and your own. Zix, that simple idea that perception is union, turned scientific observation into something sacred. It meant that seeing was no longer passive, it was participation in creation itself. At Paranal Observatory, Dr. Lina Alvarez described her final observation night in language that sounded more like poetry than physics. "The telescope doesn't just collect photons," she said. "It collects awareness. Every image is consciousness, meeting itself halfway." Her colleagues smiled, half in awe, half in agreement. Because after all the data and analysis, after every model and simulation, What remained was the ineffable sense that knowing the universe and knowing ourselves are the same act. For centuries, philosophers have whispered the same truth in different forms. The Upanishads called it Tattvam Asi, you are that. Spinoza called it Deus sive natura, God, or nature. Einstein called it the cosmic religious feeling. All of them, in their own languages, were describing the same event: consciousness recognizing itself through the fabric of existence. When scientists tracked 3I, Atlas, they thought they were tracing an orbit, but what they were really tracing was the arc of attention, the way awareness moves from fear to wonder to peace. The object itself was secondary. The true event was the awakening that happened in those who watched. Each telescope became a lens of self-realization. Each calculation, a meditation. Each hypothesis, a confession of longing. By the time the final reports were written, even the most skeptical researchers spoke differently. They still used the language of science precision, probability, verification, but underneath was a current of quiet reverence. We are the universe becoming aware of its own motion, one paper concluded. It was an academic sentence. But to those who understood, it felt like prayer. This blending of the empirical and the existential marked a new chapter in humanity's story, not the end of science, but its flowering. Because when science matures, it doesn't discard mystery. It learns to hold it gently. At the closing conference of the 3I, Atlas Global Collaboration, Dr. Patel gave the final presentation. The slide behind him was simple: a photo of Earth taken from the JWST, a pale blue dot glowing against infinite black. He paused before speaking. Every discovery, he said, is a mirror. Every question we ask of the universe is answered through the way we listen. When we study the cosmos, we're not conquering it. We're remembering we belong to it. The second, then he added softly, almost to himself, perhaps knowledge was never about mastery, but about meeting ourselves through the vastness of everything else. That moment was streamed to millions. For a few seconds, the feed lagged just a static hum over the image of Earth. The silence, strangely enough, became the message. Because it was the same silence that fills the space between stars, between atoms, between thoughts. The silence that allows everything to exist without needing to speak. This was the lesson 3, I, Atlas, left behind. That observation is not domination, and understanding is not possession. That awareness is the bridge between subject and object, between matter and meaning. To look into the night sky is to look inward through the longest possible mirror. Every photon arriving at our eyes is ancient, older than language, carrying the same secret. You are part of what you're looking at. In quantum terms, it means the observer is entangled with the observed. In human terms, it means the heart and the cosmos share the same rhythm. And when that rhythm is felt, fear dissolves into reverence. Separation gives way to belonging. Science gives way to silence, not as the end of inquiry, but as its perfection. Dr. Alvarez later wrote in her journal, "We thought we were watching the universe. Then we realized it was watching back, not with eyes, but with being." Her words traveled far beyond the scientific community. They appeared on meditation forums, in philosophy essays, and in songs. Because they named something, people everywhere had begun to feel that knowledge, at its highest expression, becomes love. For love is the recognition of self in another. And what else is science, if not the slow recognition of ourselves in everything we once thought was separate? The machine's OrbNet, Astro AI, the telescopes, the algorithms were instruments of that love. They extended our senses, stretched our attention, and allowed consciousness to meet itself across light years. The data was objective, the meaning was intimate. And so, in the end, it became impossible to tell where the boundary lay between physics and philosophy, between measurement and meditation. The deeper truth revealed by 3I, Atlas, was not hidden in its trajectory, but in our own reaction to it, the journey from fear of the unknown to communion with it. When the universe becomes a mirror, we no longer ask, what is out there? We begin to ask, what is looking? And the answer comes softly, like starlight across time, the same thing that dreamed the stars into being. At the close of the final documentary, Dr. Patel's voice returned one last time, his tone serene. Perhaps consciousness was never confined to us. Perhaps it was always the light itself, learning to see. The image faded to black, replaced by a single line that hovered on screen. The universe observes and becomes. And then, silence again, vast, full, and alive. It was the perfect ending, because in that silence, the observer and the observed were one. Part 15. The Stillness Beyond Discovery. The last night of observation arrived quietly, without ceremony. No countdowns, no press releases, no live feeds, just the faint hum of computers finishing their final scans. The telescopes that had watched 3I, Atlas, for months, now rested, their mirrors cooling under the breath of the desert wind. On the monitors, the object's light had already faded beyond the threshold of detection. What remained was not data, but a feeling, the soft echo of wonder that comes after comprehension. In the silence of that moment, it became clear that discovery had never been the destination. Discovery was the door, and the stillness beyond it was the truth. The scientists didn't cheer or mourn, they simply sat with it. The awareness that they had witnessed something extraordinary, not because it was spectacular, but because it had allowed them to experience their own capacity for awe. All the noise, all the speculation, all the fear, they had dissolved into what every genuine search for knowledge eventually becomes: gratitude. Gratitude for the vastness that does not require our understanding to exist. Gratitude for the chance to witness it, however briefly. Gratitude for the humbling reminder that the unknown is not our enemy, but our oldest teacher. Dr. Lena Alvarez closed her last log entry with a single sentence. The universe doesn't need us to look at it, but it allows us to. Outside, the wind moved gently through the domes. The sky above Chile shimmered with stars, the same as always. Somewhere out there, 3I, Atlas continued on its silent trajectory, receding into the dark, a comet, a fragment, a messenger that asked for nothing but attention and received devotion instead. For months, humanity had tried to interpret it as signal, as threat, as miracle. But now, in its absence, a new understanding emerged. It had never been any of those things. It was simply real. That was enough, because the more we learn about the cosmos, the more we see that its beauty lies not in what it gives us, but in what it allows us to become in response. Every discovery is an awakening, not to the external world, but to the dimension within us that can meet infinity and not look away. In the control room, Dr. Patel sat before the console one last time. On his screen, the final coordinate flickered faintly 3:14 UTC. The line graph flattened into equilibrium, and the cursor blinked, steady and unhurried. He took a deep breath, then turned off the display. It felt like closing the last page of a sacred book. He whispered, almost inaudibly, "It's never the answers that change us. It's the listening." The sentence lingered in the empty room, resonating like a soft note of music long after the sound had vanished. Outside, the night was completely still. It was then that the meaning of the entire journey became undeniable. Every telescope, every simulation, every hour spent decoding silence, all of it had been humanity learning how to listen again, not for proof, not for reassurance, but for a relationship. For centuries, we had tried to master the universe through equations, through power, through conquest, but 3I, Atlas, reminded us that to truly know something vast, we must first be quiet enough for it to know us. The scientists who had once feared its approach now spoke of it with tenderness. The journalists who had once written of catastrophe now wrote of humility. And those who had once stared at the sky in panic now looked upward in peace. Because they understood, nothing had ever approached Earth. We had been approaching understanding. For the first time in generations, the entire species felt aligned, not by fear, not by faith, but by shared wonder. The world had stopped spinning just long enough to notice its own reflection in the stars. And in that reflection, people began to see differently. Not smaller, not insignificant, but right-sized. A conscious part of an immense and benevolent geometry. Months later, when the last data archive was sealed, the scientists gathered under the open sky. No lights, no speeches, only silence, the most eloquent language they had ever known. One by one, they looked up. The Milky Way stretched across the night like a thought too vast for words. The air was thin and cold, yet every breath felt infinite. Someone said softly, "Maybe the universe isn't expanding outward. Maybe we're expanding inward." No one replied. They didn't need to. The meaning hung between them like the starlight, immediate, self-evident, and eternal. Later that night, Dr. Alvarez wrote her final reflection for the archives. There is a kind of awakening that happens when you realize you don't need to reach the edge of the universe to feel whole. You only need to reach the edge of yourself. Her words would become the final line of the 3I, Atlas documentary. As the film closed, The last image showed Earth from space, a pale, luminous sphere drifting through an ocean of black. The narration was gone. There was only sound, the faint hum of solar wind, the breathing of eternity. Then, slowly, a sentence faded onto the screen. The universe never moved toward us. We moved closer to understanding it. And for once, humanity didn't scroll away or demand more. They simply watched, in silence. Because silence, they finally realized, is not the absence of knowledge. It is the presence of meaning too vast to name. That is what 3i, Atlas, had taught, that discovery is sacred, not because it answers questions, but because it awakens reverence. Every generation believes it stands at the threshold of understanding, but perhaps understanding was never the door. Perhaps it was the stillness waiting behind it, the space where science and spirit, reason and wonder become indistinguishable. The cosmos had not changed in all these months. The equations had not bent. The stars had not rearranged themselves. What had changed was the human heart recalibrated to the frequency of awe, and that, more than any calculation, was the true discovery. When future astronomers look back on the era of 3i, Atlas, they may not remember the numbers or the coordinates. They will remember the silence the moment the planet stopped, fearing the unknown, and began to listen to it instead. Because there, in that listening, lies the eternal relationship between the finite and the infinite, the meeting point where light becomes meaning and meaning becomes peace. The stillness beyond discovery is not emptiness. It is completion, not an ending, but a return to balance, to belonging, to the quiet rhythm that connects every atom of existence. Somewhere far beyond the range of telescopes, 3i, Atlas, continues its journey, a faint ember drifting through interstellar night, carrying the memory of a world that once mistook it for a threat and later thanked it for a lesson. It will never know what it gave us. But we will remember, because every so often, the universe sends us teachers disguised as mysteries, and when we finally stop trying to solve them, we begin to understand what they were saying all along. The stars keep burning, the sky keeps breathing, and humanity, for the first time in a long time, has learned to do the same. The telescopes are quiet now, the data streams have ended, but the awareness remains clear, unhurried, infinite. The journey didn't end when the object disappeared. It ended in us, in the stillness it left behind, vast enough to contain every unanswered question and every quiet truth. The universe never moved toward us. We moved closer to understanding it,